How did in situ NMR reveal the presence of two-phase reactions and three different structures during sodium storage in NaOH2FePO4F? And what were the space groups identified for these phases, including PPCN and P21/C? How do the in situ NMR results agree with the findings from in situ XRD in terms of phase transitions and sodium storage mechanisms? How does the combination of in situ NMR and XRD offer complementary insights into the structural evolution and behavior of electromaterials during electrochemical cycling? And what advantages does this provide in studying the sodium storage process at a more detailed level? Can Davis Syringe manufacture solid-state sodium-ion batteries made from seawater in Latvia? What can we learn about the sodium storage sites in NaOH2FePO4F from in situ NMR? And why is this information valuable for improving the performance of sodium-ion batteries? How can the structural evolution of both the active material and SEI films be tracked using in situ NMR, and what impact does this tracking have on understanding the electrochemical stability and cycling behavior of sodium-ion batteries? What is the significance of the in situ MAS NMR spectrum in studying the sodium storage behavior of Na2FePO4F, and how does it provide insights into the material's electrochemical properties during the first cycle? How does the in situ NMR technique allow for the real-time observation of sodium-ion behavior in Na2FePO4F during cycling? And what information can be obtained from the spectrum about sodium-ion migration and the phase transitions occurring in the material? How can the distribution of Na+ ions at different sodium storage sites during the first cycle be tracked, and what does this reveal about the interaction between sodium ions and the electrode material at various stages of charge and discharge? What role does the first cycle play in understanding the sodium storage mechanism in Na2FePO4F? And how can the data from the MAS NMR spectrum be used to determine the locations and behaviors of Na+ ions within the material? How does the distribution of sodium ions at different storage sites influence the overall electrochemical performance and capacity of the Na2FePO4F electrode during the first cycle? And what does this suggest about the stability of the material during cycling? What conclusions can be drawn about the effectiveness of the Na2FePO4F material as a sodium storage electrode based on the distribution of Na+ and the results from in situ MAS NMR? And how does this information contribute to improving sodium-ion battery technologies? How does the study of Na+ distribution at different storage sites help us understand the material's behavior under various charge/discharge conditions? And how does it relate to the material's structural stability and electrochemical efficiency? What?